Hi, everyone. Thank you, Selena. Hi, and welcome to this panel on FAIR for software. I am Maria Cruz. I'm a senior policy advisor for open science at the Dutch Research Council, which is the main funder in the Netherlands. And I recently, this year, I joined Open Science NL, which is a new office dedicated to open science within the Dutch Research Council as program leader for open research software. I will now ask each of the panelists to introduce themselves, and then we'll go into the discussion. I'll start with Rina.
Can you hear me?
Yes, very well,
yeah.
Thank you.
My name is Rena Bakshi, or Rina. I am a program manager at the Netherlands eScience Center. I'm in charge of portfolio of projects in natural science and engineering domain. Netherlands eScience Center is the Dutch national center with the digital skills, so offering digital skills to develop software solutions in academic research. We champion software sustainability, open science, open source development, and FAIR principles. It's not always easy. It's sometimes challenging, but it's always fun. So that's my intro.
Thank you, Rena. Tom.
Hi, everyone. My name's Tom Honeyman. I'm a solutions architect at the Australian Research Data Commons. And for the last 3 years, I've been leading a program of work to seek recognition of research software as a first-class output of research. And naturally, as part of that, I was fairly active in the working group to formulate a set of FAIR principles for research software.
Thank you.
Yep.
Oh, go on, if you're ready. Thanks, Tom. Leila?
Hello, everybody. My name is Yael Castro. I'm a computer scientist, and I work as a team leader for the semantic technologies team at CERVEMED, the Information Center for Life Sciences in Germany. We are very interested in metadata, particularly metadata supporting research digital objects. For instance, software is one of them. And because of this, I have been involved in software recognition and research software and the FAIR principles for it.
Thank you. And Fotis?
Yeah, hi, everyone. My name is Fotis Sogopoulos. I am a senior researcher at the Institute of Applied Biosciences at the Center for Technological Labs in Thessaloniki, in Greece. That's a mouthful. Part of my job is to actually develop tools, run tools. So I was quite interested in the software aspects. In that context, and under the umbrella of the Elixir efforts, I've been quite involved in working around the FAIR principles for software, as well as defining a software management plan, and that will be lower bar enough, so that people who are not necessarily technically savvy can actually use this effectively.
Thank you. I'll start with you, Tom. So the FAIR principles were published in 2016, and they were intended for all digital objects. In this panel, we are discussing the FAIR principles for software. Could you introduce us to FAIR for software, and also why there was a need to adapt and adopt the FAIR principles to research software?
Yeah, so the FAIR principles, as you said, were first sort of really started to gain traction with the broader public when it was published in a paper in Nature in 2016, and it really lit up the data community in particular. So the FAIR principles was an easy, memorable set of principles, going beyond the simple mnemonic of findable, accessible, interoperable, and reusable, that highlighted several areas to focus energy on. And there are a set of principles, so they kind of point you in a particular direction. So for many years, people were quite happy to work away on data, but the original vision actually included, as you said, other digital objects. And it actually does name software as an area of interest in doing that, but a lot of the energy didn't actually go into how we might do this for software. So I think starting in around 2019, 2020, particularly coming out of Europe, I think there was an EOSC working group and a group out of France as well that realized that the energy needed to move towards actually clarifying what FAIR was for software. And that kicked off a joint RDA, Force 11 and Research Software Alliance working group to sit down and define what was different about software from data. And I think I probably say that one of the critical elements that needed to be captured is that the sort of public availability of software, there is a strong culture around how that's been done, that's been developed over decades, whereas actually the concept of sharing data in the way that was intended by the FAIR principles was relatively new compared to, say, the open source software movement. And there was a desire to point this out, I think, in the research software community to say, hey, okay, your set of principles are great, but however, software as an output is actually quite different in nature. The way it's developed, the way it is iterated over for the kinds of software where that happens. And so therefore, kind of the actions that need to be taken on it are different. And so the group came together to define a set of FAIR principles that applied to software.
Does anyone else on the panel would like to add, to reflect on this question on why FAIR for software? Yael, perhaps?
I would summarize the need on software is not data. And we need to understand this clearly, and we need to say it loudly. There are different elements in data, there are different elements in software, things that you need to take into account for one and not the other. And there has been recognition of this and the need of having the adaptation of the FAIR principles for other digital objects, because not all of them are exactly the same. So you need to tailor some bits in it.
Thanks. I would just like to remind the participants that you can ask questions via Slido, and I'll try to fold your, well, not just try, I'll fold your questions into the discussion as we go along. So if you have any questions related to the topics we are discussing, please add them to Slido. So we know why there are FAIR principles for software. Software is not data. That's an important message. But how do we do this in practice? And yeah, when applied, so the FAIR principles again were published in 2016, had a lot of impact in research data. That led to data management plans becoming, you know, an established practice. Funders require data management plans. Institutions require data management plans. Is that the next step, software management plans? Is that the way to put FAIR into practice? Fotis?
All right. Yes, and I can mute myself now. The longer version is basically, you're absolutely right. This is kind of the road ahead. The data management plans, to an extent, were put together because people across the wider community realize that there is a problem. We are generating loads of data, occasionally high quality data or expensive data, and people cannot really find it or use it, or basically it's somewhere there, no one knows, which is a problem. In response to that, and following the FAIR principles were in the meantime well defined, we had the data management plans. We are, I feel, in a similar position right now. Looking at a whole, we have tons of code being written, software being developed, that is to an extent developed by using public funding. But not necessarily all of it can be used or built upon or relied on. So for this reason, we do have principles, as Tom and Leah just mentioned, but at the same time, we need to have a more structured approach on how to codify this information, to manage it effectively. So having software management plans is, again, as far as I can tell, the next logical step. The main downside that currently is always the perspective. Data management plans, again, from a very practical point of view, a lot of people just see it as I need to do this extra admin thing because people ask me to. That is fine as long as they are doing it, because it slowly changes what does actually mean, what are the expectations, and ultimately makes the data more effective, more usable. A similar approach should be made for software. There are a few software management plans out there, and I'm very happy to see that efforts like the ones pushed forward by the Netherlands is a very good step in that direction. But essentially, we want management plans specifically designed for software in alignment as much as possible with different principles that are easy enough for a researcher, for an individual to put it together without necessarily requiring a lot of effort, because ultimately this will be kind of a failure.
Yes. And I wanted to go to the question of software management plans, because there are also different types of software with different types of management. And perhaps I'd go to you, Tom, to perhaps tell us about the different types of software, because we also want to, perhaps, as you say, for this to avoid, we may not want researchers to prepare data and a software management plan if it's not necessary. Tom, do you have a view to share with us on?
Yeah, so first of all, one of the first tasks that the FAIR for Research Software Working Group had to grapple with was to actually decide what was research software. And this is not a trivial problem. And the group, essentially, the definition boiled down to, well, first of all, there's a concept of the research that originates, the software that originates within research, created for a research purpose with some research intent behind it, versus the software that's used in research software, in research. And when you think about the application of FAIR principles, you're really actually applying it to outputs. But then drilling down into that, there are lots of different types of software with different types of priorities. So for instance, if you think of the, say, analysis code that gets typically associated with a publication, some people might just call these simple scripts. That's a form a tool that has been created demonstrating a new idea for other people to use, say some new method or something along those lines. And then again, there are forms of software that have been created in the context of research that have been around for a long time, in which actually a stack of people depend upon. And how the FAIR principles might apply to those three different types of software is a little bit different. When you're thinking about those simple scripts in association with a publication, it's just the primary struggle is actually just getting it out there in the first place. But it's going to be less likely, for instance, that you're going to see versioning. It's not to say that version control isn't a good thing to have over the top of that, but I think the early focus would be on minting identifiers and some of the more basic elements of the FAIR principles. When you go to the other end of the spectrum, when you take a piece of software that's been published and available for a long time, but is still supported by a research group, you're actually going to be modifying the ways in which you've made it available. And, you know, there's only so much room that you can move. You can't rename the software. Well, you could, but it wouldn't be fun. And you're going to be augmenting the practices that you've already put in place to get the software out there, how you've described it, the metadata that's associated with it, the schemes that capture the metadata. For instance, if you're publishing on PyPy or CRAN or something like that, it's going to be a different game essentially. So those are three distinctions that we use particularly at the ARDC to differentiate the kinds of tasks that might be associated with different types of research software.
Thank you, Tom. I'm seeing some questions in Slido, and there's one question about what the response be to researchers who say, but my paper will get scooped if I openly publish software and data. And there's also another argument against releasing research software and data openly that would be used incorrectly and would be inaccessible to the layperson. The question, and as such, is it only really scientists and researchers who need access? So we have, in a way, it's two questions. You know, how would we respond to researchers who are reluctant to publish their data or software because they'll be scooped, or because they feel that somebody's going to do something that they would not approve, or, you know, it doesn't matter because other people are not going to be able to do something with it anyway. Does anybody in the panel would like to address this question?
I'll have a go if no one else will. Fotis, you look like you were going to have a go. Why don't you do it?
Maybe Tom
there's a
starts
shopping list, so maybe we'll throw things out there. You know, first of all, the concept of being scooped, there is a mechanism out there. It's called embargo. It's no different for that kind of code and for data as well. And so really, that's not a huge problem. The second thing is that it's very commonly the case that if you submit your code for review, you might actually head off embarrassing mistakes in the paper. And in fact, in the longer term, it's often been for people that report, you know, positive effects of sharing their code, it's been a source of collaboration. And further, you find in some disciplines that actually this is what researchers want to read to really understand what you're doing in your paper. But I think it's particularly the case in computational biology, but it augments the paper. It actually describes what you've done in pretty succinct detail. So it's a great way of communicating. But does anybody else have any other added points?
I can try, maybe. I think I agree with what you said, Tom. At the eScience Center, we actually are moving towards a bit of drastic approach of actually forcing people to release everything from the start, exactly for the reason that you indicated, that community should be able to see and sort of peer review it, basically. Embargo is not a good enough, starts to be not a good enough reason for us, but it's just also based on a very, very long experience of people, basically using this argument to not ever release. It's never good enough. It's always this kind of argument of somebody is going to scoop. Well, you put it online, you put it on a GitHub, there is a timestamp on it, you release it, and it's there to sort of, you know, claim that you were the first developer or publisher of this. So yeah, at the eScience Center we have very radical approach, but that's not.
I'm quite interested in its approach, and I understand the approach, but in open science, and we tend to say as open as possible, as closed as necessary. And the FAIR principles, both, you know, for data, for software, don't actually require openness, an open license. But sometimes there are, researchers who are working with a company or have reasons for not to be able to share their data or software, their intellectual property rights. Some of these are not explicitly in the FAIR principles, but on the other hand, licensing and IPR, intellectual property rights, can be complex issues for researchers. These are legal issues. And can be complex, particularly in the case of FAIR for research software. So what are some of the considerations or best practices when it comes to navigate these issues and to licensing software when possible for maximum openness and collaboration, as you mentioned?
So I guess I have to, I'm answering this, right?
Yes.
So strictly speaking, IP rights are not part of the FAIR software principles, but there are a few principles in A, I, and R that touch upon licensing. But yeah, they don't call for open licensing. So I think quoting it, something goes like the license should be as unrestricted as possible. And yeah, you're right. The idea is that there are some research groups that work with the private partners and use their software, this commercial software, as part of their workflow. And it should be possible for them to follow FAIR principles, right? So know the steps how to reproduce the results. And the FAIR principles should not by themselves discourage anyone from applying them to their software. So FAIR principles tend to be abstract, so I'd like to just share the experience, how it is implemented at the eScience Center. So we're not that radical either, but let me just share it a bit with the audience. So in terms of long-term reusability, all projects funded by the eScience Center are required to have the software management plan, because we are developing actually research software in all of our projects. So, and the future IP should be somewhere there in those software management plans. In terms of findability, all project output, including research software, must be registered in our so-called research software directory, regardless of their license. And even though FAIR principles do not call for the open source license, referring to the R3 principle, our community standard is Apache 2. So our default license is Apache 2, which does not exclude researchers, doesn't prevent researchers or our project partners from coming up with a commercial model and then sort of, making the research software in some ways commercial after we, release everything on the Apache 2 license. It works best for us, for our work in our practice. But there, of course, nothing is ideal or perfect and under the same recipe. So there are always deviations. So I think referring to the same principle, R3, when we look at the licensing, we also look at the community that we are working with and the norms that they're applying. So you don't want to use the license that is incompatible with the other software, even just on the technical side of the thing or legal side of the things. So let me give you an example. We are working with, for example, climate scientists, and in principle, they are very supportive of the open source licensing. And some of their modeling simulation frameworks, for example, the ocean model has GPL license. And if you want to do development on it, you have a login screen and you have to be part of the community in order to get access to it. On the other hand, they also are using quite a bit a commercial software, which is it was developed by ECMWF, so the European Weather Forecast Organization, and the software is called IFS, Weather Prediction System. It's used as an atmospheric model. Long story short, this is not open source license. It doesn't have open source license. It's commercial product. And we had to work on one of our externally funded projects with it. Our research software engineer had to sign non-disclosure agreement on that project. But we didn't want to develop, we were supposed to develop a coupler that connects to that atmospheric model, and we didn't want to do that in a closed source. So what our research software engineer did was implemented API on the side of IFS, basically bringing IFS to the FAIR standards, a bit higher on the FAIR standards side, and applying this I principle, interoperability. And after that, he implemented coupler in Apache, on the Apache 2 license, and released it on the GitHub. So that's the story.
Yeah. I wanted to go back to something you said, community and their norms. And I know there's other questions that are more popular in the Slido, but I saw something about discipline specific. And I wondered, and I know for this, I've heard you talk about this. I wondered if you could say something about, is there a need, and Reina, you said also that the FAIR principles are very high level. Is there a need to translate this to different disciplines and their norms? Is there something you would like to talk about for this?
Not necessarily. I think principles are principles, and I spoke to my colleague who was one of the co-authors of the FAIR principles, and he was also saying that we would like people even in the commercial world to apply the FAIR principles, just so that we know how to reproduce the results, right? So there isn't kind of a scope for the FAIR principles. So it shouldn't, like I said in the beginning, FAIR principles should not discourage people from, I think FAIR principles are upgrading the standards basically for the software, for the research software, increasing quality, because then there is like I said, information on how to reproduce the results. There are way too many communities. Our approach is just to champion our own way of doing things. Like I said, it's our community, the research software engineers community. We are championing Apache 2, whatever possible. And we're using all kinds of tricks to still end up with Apache 2 license. It's not always possible. There are, of course, lots of GPL licensed software, which is also open source, and it's just fine. Yeah, I think that would be just too complicated. Maybe communities coming together and just thinking about what they want to get. Do they want to put some restrictive license because they want to sustain the software in a certain way? It's something to come together and think about it. But yeah.
Yeah, I think I wanted to go on, move beyond licensing, but still because with FAIR data, actually there were communities that put together 10 things for FAIR in astronomy and a lot of other disciplines. So is there room for that in here as well? And I wanted to move to another panelist because Fotis, I thought you were going to unmute to talk about this.
Sure. Well, I'm happy to, and Leila, I'm sure, can provide some additional context on that front. The short answer is that, as Serena said, principles are high-level principles, so they should be applicable as SR to all communities. That being said, how you want to implement these FAIR principles might change across different communities. the fact that you want, for example, in the first principles to have rich metadata, and you have a registry about that. In life science, you might be using a different registry to deposit your research software as opposed to another community, for example. So the way that you want to implement that might change from community to community, having some recommendations on how to make your life easier. Because ultimately, you want to follow the first principles. The way you want to follow them, you want to be as low barrier as possible so that you don't spend too much time on these things. Ultimately, if I can summarize that, the key goal would be to make sure that the principles and what they mean in practice becomes part of the norm. So be that a research software engineer or a researcher or a master thesis student, everyone who's actually putting together software should have this as part of their own perspective on how things should be done. More or less, if you do that, you'll find the corresponding tools, services, infrastructure that will help you make this as fair as possible in this particular context.
I wanted to move on now to recognition and to research assessment with the Coalition on Research Assessment globally. There's a lot of momentum to change the way researchers are assessed. There are a couple of questions on Slido related to this. One is to do how fairness of software, is fairness of software measurable? What does success or failure look like? And also there's another question about tracking the different input to software as it develops, and therefore citing those who've had a role. Well, it's a statement actually says it's complicated. How could or should this be recognized? So I wanted to move now to the role of the FAIR for software in facilitating or supporting recognition for software. Yael, would you like to come in here?
I want to start by saying that scientometrics is not my area of expertise. And research assessment, yes, I am aware of ongoing efforts, the COARA coalition, for instance, and other efforts at national and international levels. However, I'm not actively participating in any of those projects at the moment. That said, as a researcher and a researcher working with research software, I am interested in the recognition of software. And I'm interested in these at different levels. So I think there are some elements in the FAIR principles that are supporting the direct recognition of the research software. For instance, the FAIR principles talk about describing the software with metadata. And later they said that they should include a plurality of accurate and relevant attributes. And they also talk about associating software with detailed provenance. I would say that authors, contributors, editors in a software development, they are part of the metadata that we should expect from software. Another important aspect here that I see directly in the principles is that different versions of the software are assigned different identifiers and, well, the identification of the software as a whole as well. Because we know that if we are dealing, for instance, with a software that has been there for years and is expected to keep going, one big research software project, for instance, the people involved in the development will change over time. And you want ways to give the recognition to those that participated in a particular release. So having different PIDs for different releases and having the clear attribution who participated in the development of that software, and even more, what role they play in it, it's an important step towards recognition. This is also, I would say, related to the citation of the software, and also to get the credit for what you do. So let's suppose that you decide that you cannot make your software open for some reason. You still can provide a metadata. And in the metadata, you can be attributed as an author or as a tester, for instance, or as someone who helped designing the user interface, if there is a user interface in there. So there are ways for people to see who was involved in a software development, and I think this is important. And it's not only those who directly create the codes. We have many more roles in software development.
There's actually a question here about the difference between, it relates to this, let me find it. There's, yeah, do you think that we should find a different way to speak about code associated with an individual's result and software that's being used by many researchers? The two seem to be, this moved, but actually it relates again to this reform of research assessment that is also trying to move from focusing on individual achievements into more collaborative achievements. Is there anybody in the panel would like to speak about this? Oh, for this?
I can give it a shot. So I may be completely wrong here, but looking at the different aspects, so it's the code that is developed for someone to use versus a code that is part of a research project, for example. I would argue that both of these, in the context of FAIR principles at least, should be part of the same process. If you're talking about a code which is associated to the result, you want this code to be part of the, to adhere to the FAIR principles, if anything else, someone who is going to be using these results to assess that it's run correctly, that you can build on this output and so forth. So ultimately, even this code will be, to use the same phrase, stuff that is going to be used by many researchers, the many being a number. It could be 4. Is it big enough? So ultimately, the FAIR principles should always, like, let me put the other one, research software should ideally be following the FAIR principles. The more you can follow the FAIR principles, the better. It's not a 0-1. It's not either fair, not fair. It's a gradient. So the more you can align and you follow the FAIR principles for the community that you're serving for, and ensuring that the information provided is accurate enough, the easiest will make it for everyone, either to assess the results or continue working on your code. The sustainability aspect, which I think is kind of implied in the question itself, is not necessarily part of the FAIR itself. I mean, fairness is a first step for sustainability, but you cannot, at least as far as I can tell, it's not the solution if you're talking about sustainability. It requires much more of a support and structure by corresponding institutions, the communities that actually use software to make sure that there is a sustainability aspect. But the first step, even in that direction, is always to talk about FAIR.
This actually relates, oh, Tom, go on, but because there's also a question here about what are the key training skills areas that present barriers to FAIR software? I don't know if you want, Tom.
Can I go back to the, can I just add one more thing to Fotis's point? I think the distinction between the two becomes even, you know, I completely agree we need to make both fair, and that's, and what you need to imagine is an ecosystem where there is a lot of fair software out there, but the distinction between that kind of project code and the code designed for other people to use is that project code is often the connective tissue between a research finding and the underpinning pieces of software that are dependencies in that code. And actually, we need that evidence out there for those poor people who built that software underlying that project code, so that they can demonstrate a connection between what they're doing and the actual impact that it's having on research upstream as well.
I would like to add something there. There are different ways to create collaborative software. Even if a software is individually created for a very individual purpose, if you share it, then you are enabling others to see what you did, to learn from what you did, even if you do it as an individual, only one person, only one purpose. Others can still benefit from it, and that is already a collaboration. So I don't see this kind of individual versus collaborative. No, there are different levels, different ways.
Thank you. That's a really good wrap up to this part of the discussion. I also want to try to address as many of the questions in Slido. And one is about one challenge for fair software is code rot. Dependencies can go missing over time. Bugs might surface once new compilers are released, etc. This means interoperability and reusability can decay over time, as can reproducibility. Does the panel have any ideas on how to tackle this issue? And is anybody on the panel who would like to answer this question?
I can just share the experience from the eScience Center. We usually use best practices, which is Dockerization, for example, of the software, so that you have a particular sort of versioning of compiler and all the dependencies all in one package, kind of best practices on the release. You can't do it, I think, unless somebody on the panel knows better way. I do not know a better way at the moment, but that's how we implement it. It's not per se fair, or it is in a sense that we still release that image, basically Docker image. If we think that the dependency is very heavy of the software that we developed.
Go on, yeah.
So if I may, we need to remember that fairness is not a magic wand. It's not that we are fair, yes, everything is sorted. No, we have still quality, we have reproducibility, and the world changes. So having a software being fair, it doesn't mean that the software will not go into deprecation ever. Still, it could happen because the Python version that we used is no longer supported. We need to react to it. Maybe we need to move to a different way to do things. Maybe a company decides to close a library that used to be open, and it was open until certain version. So we still need to do maintenance to the software, and we still need to do management of the software. So we need to react to the changes as they come.
I think it's also important to remember that full spectrum of software as well. So when you're dealing with that project level code, what you're doing is you're more at the integrity end of the spectrum. You're demonstrating how you did your research by making the code available. And it goes to actually capturing the execution environment at the time that you ran that code. And it's not necessarily about the maintenance of the code. And so there isn't, the problem is of a different nature when we're dealing with that end of the spectrum. And I think, but the pattern is the same in the abstract. So Docker is a particularly good way, or it's a particularly common way, I should say, of capturing execution environments. There are more high-minded systems out there that parameterize it, like GUIX, that are, more friction to get into, but perhaps from a computer scientist's perspective, a more elegant solution. But generally speaking, what you're trying to achieve is the capturing of the execution environment to the degree that you can. And that is actually in the abstract there in the FAIR principles when we're saying metadata in association with the software. There is this, essentially, it's an endless task. You can keep adding more and more valuable metadata about the software. At some point, we're all going to die and you're not going to be able to document it anymore. So, but nevertheless, that's what we're trying to get at is, describe it as much as you can at this stage within reason, because, if you're publishing several papers a year, it's a lot of work. If you are working on a piece of software used by hundreds of thousands of people around the world, well, it's a different story again. Like, do a good job of putting good metadata in association with your software.
I wonder, I already phrased the question, but I wondered if we could come back to it because, yeah, the barriers you mentioned, Tom, yeah, I've lots of papers to publish, don't have time for all of this, but also I've heard a lot of words and I know some of them will not be familiar to researchers. Docker containers, not all researchers know what that is. So can we speak a little bit about training and then the skills that are needed to put FAIR into practice? Would somebody like to say something about that?
May I add something to the previous point?
Yeah, sure.
I just wanted to say that the sort of, like everybody said, the FAIR principle is not this golden recipe for magically resolving all the dependency issues and upkeeping your software forever. If that was the case, then we would have had a bunch of very happy lead applicants and a very, very nice environment to develop research software. But part of this sustaining software and making sure that it doesn't get obsolete in the long term is this software management plan, right? So this push for the software management plan and asking researchers to write how are they going to go about sustaining their research software after the project ends, right? And quite often we also advise researchers to embed the sustainability part into their teaching activities, that they sort of involve master students or PhD students, or just, giving it as a part of the course, basically training the new generation of researchers, getting familiar with the software such that they can build a community and contribute to the further development of the research software, such that next time it doesn't break when the compiler is just not there, or version of the compiler that it depends on is not there anymore. Yeah.
And with that, it feels that we're back at software management plans. And Fotis, I'll go back to you. Is that the solution for training? Because with the data management plans, and as much as, I know some researchers resented it, but that also at the policy level, at least here in the Netherlands, there's a lot of investment in training just because we are asking for data management plans. Is the software management plan sort of a pathway to that training?
Well, the short answer is yes. The way that it was developed in the get-go, or any kind of software management plan for that matter, is by making sure that the people who will be assessing that, will be involved in that, actually had the say in the definition of the plan itself. So any kind of a management plan, data, software, whatever, has the context of being aware of what are the individual components there. So by that definition only, it is a very good training tool. So short answer is yes, it's a very good thing to start as a training effort. But ultimately, what I want to reiterate mainly is that it is important enough to ensure that any kind of management plan, and this is not just for software, I'm fairly certain that down the road we'll have additional management plans for other research outcomes that are equally important. It is important to make sure that it is easily enough for everyone to fill it in without necessarily having specialized knowledge. Not going into extreme detail on the technical aspect, for example, like about code, but making sure that the key components, the key aspects, the decisions that need to be made into using it or making available or anything else are clearly stated in the plan itself. In that way, you will ultimately have more impact, not only for training people, but actually making sure that this kind of perspective of changing what you need to capture for any research software is made part of the overall culture in research software development.
Thank you. And we have 6 minutes left. I almost can't believe it that we're almost at the end of the hour. It's been such a fascinating discussion. I'm not sure I've managed to ask all the questions in Slido, but I think the panelists can go back and answer some of the questions. But there's a question I really like, so I think it's a nice way to finish on an inspiring note, because in the end, yeah, sure, fairness and fair is not going to be a magic one, but the idea here is that software is reused, that we get maximum impact from software that has been created. So there's a question that I think would be a nice question to ask all the panelists as a final question. Have the panelists got inspiring examples of software being reused for another purpose? But panelists, fear not, if you cannot think of anything in the spot, we could also finish and yeah, what you see as the next steps for FAIR. So either next steps for FAIR or an inspiring example that, you know, that really inspire people to do FAIR. And please don't take more than 1 minute per because we want to ensure that we finish at the top of the hour. Who wants to go first? Sorry. Tom?
I'm going to steal one from, I love the story from the Netherlands e-Science Center where there was there was a conversation at a table around Word2Vec, which is a text analytics tool. The person was talking about mass spectrometry, and they're like, oh, that sounds like you're applying the same process. And Spec2Vec was born, I think it is, right? But there are other famous examples as well, you know, the same image matching algorithm in astronomy to spot stars being reapplied to spot sharks in the ocean. Really, the magic there is creating the context in which people spot the problem. But software is absolutely ripe for that kind of stuff.
Thanks for spotting the stars to sharks and the problem. Beautiful. Who wants to go next? Just for this. Oh, Rena, you are muted. Go on.
Yeah, I have lots and lots of course, examples in my head from our portfolio. We have, of course, Spec2Vec. We have also a multi-physics, multi-scale multi-physics modeling framework. It's called it started as Amuse because it was used by the astrophysicist. It was at some point taken over in one of our projects. We adapted it to the climate scientists, and they started using it for the ocean, so it became Omuse. And now we're trying to use Omuse for the energy transition projects, so yet another domain. And now the original developer of the Amuse came back to us and say, well, let's sit together and bring back all these communities together and create one big muse for it. So that's the kind of humorous story from the eScience Center, I guess, on the use of the software across the different domains. The point is, of course, the communities, right? I mean, bringing communities together that they can develop and further sustain the software. A FAIR principle is very important, of course, there as well.
Thank you. We have 2 minutes left. 1 minute for POTUS, 1 minute for Yael. Who wants to go first?
All right, I can give it a quick shot. The only kind of pops up because I've been playing around with it is a tool that was recently used to the data management, not developed by here, but was one of the Elixir things, and realized that instead of trying to reuse everything and start from get-go, basically took the exact same platform and adapted it to make sure that we can run software management. And recently we are doing the same thing for another type of management part. So we basically took the thing that we realized was there and changed it to do our thing, and it's still the same software.
Thank you. Yael, you have the final words.
My final words will be kind of an echo of the first words of Tom in regards to this question. We have also reused Word2Vec for graphs and we have used it for protein sequences, for instance, that were not canon of the classical text that was first thought for this one. But maybe I would also like to take the opportunity to what is next. What is next is adoption, I would say. And for adoption, we need to get used to the FAIR principles, to know them, to make them, to honor them, to see the advantages, to start convincing ourselves, to convince others, to, as Rena's mentioned, for instance, also we need to take this at a master level in the universities, bachelor level in the universities. Students need to get involved early with this. As Fotis mentioned, we will make it easier, for instance, with the software management plans, and there will be other opportunities. And then we will start looking at the sort of serendipity that Tom mentioned about software being used for a totally different purpose than the initial one. And FAIR is not the answer to everything, it's not a magic wand, but it is a very good starting point.
Thank you. I couldn't have wished for better concluding words to this panel. I want to thank all the panelists for this discussion. I want to thank also the team at SSI for supporting us in this panel, Selena and colleagues, and for inviting us. I've enjoyed it very much, and I hope you all enjoyed it too. Selena, any final words from the organization?
Yes, I just want to thank you, Maria, for chairing the panel, and I want to thank all of the panelists for their valuable insight. I think it was a really interesting session, and I hope our participants got a lot out of it. We'll be answering the questions from the Slido, hopefully, and we'll let you know once that's done. And I just want to thank all of our participants for signing up and also attending the event and submitting your questions. And we hope to see you at a future Resource Africans. Thank you, everyone.